Hello, this is Juan Loaiza, and today I'm going to introduce you to the new Oracle Exadata Database Machine X4-8. I'm going to pause for a minute and let you read our safe harbor statement. First, I'm going to give you a quick overview of what an Oracle Exadata Machine does. So we've designed the Oracle Exadata Database Machine to be the ultimate platform for all database workloads. That includes OLTP, warehousing, database as a service, and also a new generation of in-memory analytics processing. There's two main parts to the Oracle Exadata Machine. There's the hardware and the software. So in the hardware, we have a very modern, fully scale-out architecture that includes scale-out servers, intelligent storage, and unified InfiniBand connectivity with cutting-edge PCI flash. On the software side, we have a lot of specialized algorithms at the compute, storage, and networking layer that dramatically improve performance and cost. And an important part of an Oracle Exadata Database Machine is that it's a highly standardized platform. It's identical at every customer, and every customer has an identical configuration to Oracle development and Oracle support. It's a very highly optimized platform. We've optimized everything from the firmware to the software to the hardware. Everything is optimized end-to-end to provide dramatic performance improvements. Also, it's a very hardened platform. It provides extremely good levels of availability. We've tested all the different failure modes and we've fixed any issues that might be there. Also, we have very specialized support offerings for Exadata, including Platinum support, which is the highest level of support offered by Oracle. Let me start by giving an overview of the Exadata X4-8 hardware architecture. And Exadata has everything you need to run an Oracle database. That includes database servers, networking, and storage. Each of these components is highly optimized. For database servers in an X4-8, we use two very powerful 8-socket servers. These servers have a total among them of 240 cores of processing power, and they support up to 12 terabytes of DRAM. So it's an amazing amount of DRAM in one system. We use a unified ultra-fast InfiniBand network in the X4-8. We use 40 gigabit InfiniBand both for server-to-server communication and server-to-storage communication. We use standard 10 or 1 gigabit Ethernet to talk out of the Exadata to the rest of the data center. And probably the most unusual part of an Exadata database machine is the storage. So instead of a traditional storage array, we use intelligent storage servers. So we're actually using two-socket Intel socket-based servers for storage. So in the case of an X4-8, we have 14 two-socket servers that have very large disk drives and lots of flash that we use for storage, and we write software in those storage servers to offload database processing from the database into storage. So we have 168 cores of processing power just in the storage, and the storage can have up to 672 raw terabytes of storage of disk drives and 44 terabytes of PCI flash before compression, which then is further expanded by PCI level compression that we have in our Exadata flash cards. And you can expand the Exadata X4-8 hardware from one rack all the way up to 18 racks by just adding cables. All the switching and everything is already included in the servers. The thing that makes Exadata really unique is all the special software that we've written specifically for Exadata. So let me go through that. So first of all, we have database offload software in storage. So I mentioned that for storage we use two-socket servers, so we have a lot of compute power in storage. So we're able to offload data-intensive query operations directly in the storage. So instead of running data-intensive operations in the servers, we run it directly in the storage right next to the disk and flash where we can operate it much more quickly. Using our offload, we can achieve 100 gigabytes per second of SQL data throughput per rack, which is an extraordinarily high level of data throughput that no one else in the industry can match. We also have very special algorithms for things like storage index data skipping that skips data that's not relevant to a query. We have special security algorithms. We have special decryption algorithms. So there's a lot of special software that we're running inside an Exadata storage server. We also have very specialized PCI flash in Exadata. So a lot of people have flash. We use our flash for smart caching of database data. So because we know the database algorithms and how it's using flash, how it's using data, we're able to cache just the relevant data in flash and do it very quickly. Using our PCI flash in an Exadata X4-8, we're able to achieve 2.66 million database IOs per second in a single rack. And these are full end-to-end from database all the way through to storage and back, and these are full AKIOs. We also have ultra high-speed flash compression, so we're able to compress data as it goes in and out of flash at full flash data rates with absolutely no overhead on any of the database processing. And we also have specialized algorithms to speed up transaction processing by speeding up log writes, which are very critical latency sensitive aspect of databases. In Exadata, we have a very specialized form of compression that we use called hybrid columnar compression, which is extremely efficient. It can provide typically 10 times database size reduction. We also have specialized messaging software. So not only do we have the fast InfiniBand hardware, we run specialized database-specific protocols over that hardware to make it super fast for database. And these protocols provide both extremely high throughput and low latency and very high reliability for database processing. We've also written a lot of database-optimized quality of service, so we can prioritize requests end-to-end from database servers through the network and through the storage in a very efficient and database-specific fashion. So we can have databases that are higher priority than others, we can have requests that are higher priority than others, and we can do this at a very fine-grained level beyond what anyone else can do. And Exadata is also a very highly available platform. Within the hardware, we have redundancy at all levels. We support all our database high availability features like Data Guard and RAC, ASM, Golden Gate. But within the hardware itself, we also have extremely fast recoverability. So for example, when a database server fails, we can recover it extremely quickly. When a storage server fails, we can recover it in just single-digit seconds. Switch failures are almost instantaneous failover. We have extraordinarily fast backups in Exadata because we can push a lot of the backup work into our intelligent storage. And we've also written a lot of software that checks configuration and status across the entire rack, everything from storage to network to OS to drivers to database software that validates and assures that everything is working properly. I just talked through the unique software features that are available only on Exadata platform. So now I want to focus on the Exadata X4-8, the specific platform that we're introducing today. Now Exadata is split into two broad families, the X4-2, which is based on 2-socket database servers, and the X4-8, which is based on 8-socket database servers. The X4-8 contains two very powerful 8-socket servers. Each of these servers has 120 cores of database processing. So each of these servers is an extremely powerful server. It's the equivalent of one of the huge SMPs from a few years back. Each of the servers also has a massive amount of memory. So they come by default with 2 terabytes of memory, but they're expandable to 6 terabytes of memory each, which gives a total of 12 terabytes of memory for database within a rack. The storage and networking is identical in the X4-8 and the X4-2 platforms. So it uses the exact same storage servers and the exact same InfiniBand network and also the exact same capacities. Now, the 8-socket Exadatas have a long history of being used for large-scale OLTP and data warehouse workloads. And those all still apply. But today I want to focus on a couple of newer use cases, which are database as a service and database in memory. Both of those are interesting because they require very large amounts of memory together with very large amounts of processing. First, I want to talk about database as a service. The X4-8 is an amazing platform for database as a service. When you're bringing together lots of databases in a consolidated environment, the bottleneck tends to be memory. You tend to run out of memory well before you run out of compute power. And as I mentioned, the X4-8 has massive amounts of memory. So this will allow dozens to hundreds of databases to all be consolidated together. Very key to consolidated environments, database as a service, is the ability to support mixed workloads extremely efficiently. When you put lots of databases together, you have an inherently mixed workload environment. You'll have many OLTP databases running simultaneously. You'll have some databases running reporting and ad hoc analytics at the same time. You'll have data marts and data warehouses running. You'll have loads and backups. You'll have in-memory analytics running. So you'll have all kinds of workloads running simultaneously, and the fact that Exadata can support all the different kind of workloads with extraordinary performance, everything from warehousing to high-end OLTP to any kind of batch, makes it a great platform for database as a service. And then the other key thing about database as a service is you have to isolate these workloads. So you don't want one system, one database overwhelming every other database that's on the system. So in Exadata, we provide extensive CPU, network, and I/O prioritization and resource management. We can prioritize both at the database level, at the network level, and at the storage on an I/O by I/O basis. So all these things together make the Exadata X4-8 an excellent platform for hosting database as a service. Now I want to talk about how Exadata X4-8 is a great platform for our new Oracle database in memory option. So first of all, when you're talking about database in memory, you need a lot of memory. And as I mentioned, the X4-8 has a massive amount of memory. So we have up to 6 terabytes of memory on every node. And when you combine that with the memory compression that Oracle Database in Memory brings, which generally ranges from 2 times to 20 times, you can get tens to hundreds of terabytes of data directly in memory in an X4-8. The other key aspect of in-memory processing is performance. So our Oracle Database in Memory option can run orders of magnitude faster SQL using the vector processing instructions that exist already in the X4-8 processors. And also in X4-8, our Oracle Database in Memory algorithms understand the topology of an X4-8 and especially schedule in-memory processing so that it runs on local DRAM of each socket. So when we're running an algorithm on a socket, we preferentially try to access DRAM that's local to that socket to get the fastest possible access. And that helps accelerate the whole throughput by a substantial margin. The other thing about an X4-8 is it has these large SMP processors. And SMP processors have an advantage for in-memory processing because each core in the server can access all the memory in the server. So normally if you have a clustered scale-out configuration, you have to distribute SQL across all the nodes, and there's a certain amount of overhead associated with that. In an SMP architecture, you can directly access all the data using the super high-speed memory interconnect. And in X4-8, we can do that, and also when we need to distribute queries across the nodes, we can use our super fast InfiniBand network to make that run really fast also. The Oracle Database in Memory option includes a unique feature we call in-memory fault tolerance. And this feature is available only on engineered systems like the X4-8. The goal of in-memory fault tolerance is to keep the system available even though a node crashes or aborts. And the idea is we duplicate the in-memory column structures across the nodes of a cluster. And this is very similar to how storage arrays mirror data across disk drives. So if you lose one disk drive, you can just access the data on the remaining disk drive. We do something very similar here. We duplicate the memory, the column vectors across the nodes of an X4-8 cluster. And this can be enabled by the user for specific tables or partitions, so you don't have to duplicate all the memory. You can choose to just duplicate the memory for recent or important partitions and maybe leave historical stuff unduplicated just to save some more memory. And the benefit of the fault tolerant feature is that if a node goes down, you can continue accessing as if nothing happened because you just simply access the duplicate copy that's on another node. Contrast this with other in-memory databases where if a node goes down, it takes all its memory with it, and then you have to wait, usually many, many minutes, for that memory to be loaded onto some other node. So this is a much more effective architecture, and it's really enterprise ready. Most enterprises don't like to wait many minutes or hours even to get their database system running again after a simple node crash or database crash. And that's exactly what you get on an X4-8. You get in-memory fault tolerance, which is a unique feature of engineered systems. The X4-8, like all Exadatas, has a unique storage tiering architecture. The idea of that architecture is to get both the best performance and the lowest cost in a single system. So we're able to keep the hottest, most active data in memory, in our in-memory formats, we're able to keep a little bit less active data entirely in flash, and we're able to keep colder data that's less active on very low cost disk. So this has a lot of different benefits. For one thing, the size of the database is not limited by the size of DRAM like it is for a pure in-memory database. So we can get as good or better performance as a pure in-memory database, but without being limited to the size of memory. We can have databases that are much bigger than memory. Another big advantage is that we're able to achieve higher performance at the flash level than an all-flash storage array. Because of our scale-out architecture, our InfiniBand, our intelligent storage, and all our Exadata special algorithms, we can achieve higher I/O performance than a pure all-flash array. And furthermore, we have an advantage of cost also. Because of our hybrid columnar compression combined with the massive amount of low-cost disk in an Exadata, we can achieve lower cost per byte than a conventional storage array. So in an Exadata X4-8, you blend all the different benefits: higher performance than a pure in-memory database, higher I/O rates than a pure flash system, and lower cost per byte than a traditional storage array. And it's all possible because of the special algorithms that we implement at every level of the hierarchy. And it's also all transparent to the application. So when we run a query, it can actually transparently use data that's in memory, data that's in flash, and data that's on disk, and blend it all together seamlessly without any input or interaction from the user. It's all completely transparent, and it provides the best of all worlds in one package. Now that I've talked about some of the use cases, let me come back and talk about how the new Exadata X4-8 compares to our previous Exadata X3-8 machine. And the main picture here is that X4-8 has much more compute, flash, and storage capacity than we ever had before. So in terms of compute capacity per rack, we have 50% more database cores than we had before, with now 240 cores of the fastest Xeon processors on the market. We allow up to 3 times more memory than we did in the X3-8, now up to 12 terabytes of memory in a rack. We're using a new generation of InfiniBand PCI 3-based cards that allow up to 2 times faster InfiniBand processing. And also we're using larger local disks inside an Exadata X4-8, which actually enables consolidation further by allowing more, for example, Oracle Homes and other data to be kept locally. In the storage, comparing an X4 system to an X3 system, we've doubled the physical flash memory. So previously we had 22 terabytes of flash memory using PCI cards. Now we have 44 terabytes of flash memory. We've also further doubled the flash memory using our flash compression. So I mentioned that we have compression algorithms that are built in hardware in our flash cards that can double the amount of flash and do this completely transparently to the application, and also run this at full data rates with absolutely no performance overhead. The new generation of flash also supports much more I/O, so we're able to run 77% more flash I/Os. So this means 2.66 million 8K database reads and 1.96 million 8K database writes directly from SQL, end-to-end from SQL, not measured at some low level by some low-level tool. So these are real achievable numbers. We also, in the X4 generation, increased the capacity of our disk drives. So we have 33% larger high-capacity disks. So we have up to 672 terabytes of memory in a rack. And if you choose to use high-performance disks, those have doubled in size. So now we have 200 terabytes using the high-performance 1.2 terabyte disk drives. So let me summarize what we talked about with the Exadata X4 database machine. The Exadata X4-8 is a family of Exadata machines that uses 2 very powerful 8-socket database servers. So we have 120 cores and 2 to 6 terabytes of DRAM in each server. It runs all our normal use cases, which are large-scale OLTP and large-scale data warehouses. However, I focus today on a couple of new use cases, which are database as a service and database in memory. And both of these use cases are interesting because they require very large memory capacity, which is what we have in the new Exadata X4-8. I also mentioned that we have CPU, network, and storage prioritization and workload management that really help with mixed workloads that are unique to Exadata. I also talked about how the Exadata X4-8 is a great platform for Oracle database in memory because of the extreme capacity of memory and the extreme performance that we've achieved with the vector processing and the localized memory access in X4-8. We also went through our Oracle database in-memory fault tolerance, which is the way we keep databases highly available even though we have massive amounts of memory of data that's just in memory. And I talked about how the transparent memory flash and disk tiering achieve both highest performance and lowest cost together and really make it the best platform for running the Oracle database. So now I'm done with the normal presentation, and any of you that just wanted an overview of the Exadata X4-8 can log off now. But I'm going to go on for a little bit longer and talk about some low-level technical details for those of you that are owners of Exadata and really want to get into a little bit more low-level details. First, I'm going to talk about some of the low-level details of our database processors that we use in the X4-8. And these are based on the new Intel 15-core Ivy Bridge Xeon E7 V2 CPUs. In our case, we're using the fastest version of this, which is the 2.8 gigahertz version. So this is one big difference from X3-8. Previously, we had 10-core processors. Now we're using 15-core processors. In terms of memory, we now have a standard of 2 terabytes of memory that comes with each server, and that's using 64 32 gig DIMMs, and we allow expansion up to 6 terabytes of memory using 192 32 gig DIMMs. This is much bigger than before because before we had 128 DIMM slots, now we have 192 DIMM slots. In terms of local disk, we've increased the capacity of the local disk. We've doubled the capacity from 300 to 600 gigabytes. Although we reduced the quantity of disk drives by 1, and the reason for that is we're making the battery hot swappable, and I'll talk in more detail about that later. We have the same disk controller as before, but as I just mentioned, the battery now is hot swappable, and I have a diagram for that in a later slide. And in terms of InfiniBand, we're using the latest PCI 3 InfiniBand card, so that roughly doubles the throughput and allows us to make all the InfiniBand ports active. We've also increased the Ethernet ports a little bit. We have 10 1 gigabit Ethernet ports per server, and we have 8 10 gigabit Ethernet ports. So we have a lot of Ethernet connectivity out to the data center in addition to the InfiniBand throughput that we have inside the Exadata. One more change in the X4-8 is that we now allow online replacement of the disk controller battery. So you can see in this diagram here, we've taken one of the disk drive slots and replaced the disk drive in it with the actual battery from the disk controller. So you can pop it in and out just like you do a disk drive. So this allows online replacement of the disk controller battery without taking the server down at all. Now I'm going to talk a little bit about the software versions of Exadata software that go along with the X4-8. So we have 2 versions, 11.2.3.3.1 and 12.1.1.1, which are associated with the X4-8, which is essentially a maintenance release that enables the X4-8 hardware. This software is not just available on X4-8, it's actually the new software that's available on all our database machines and is backward compatible to all supported Exadata configurations. The new Exadata storage software release primarily adds support for this new hardware. So whenever you come out with new hardware, you have to add new firmware and some OS hooks for that firmware. And that's exactly what these new Exadata releases do. They add support for the new hardware in the Exadata X4-8. While we were at it, we also added support for 4 terabyte high capacity disk upgrade option to some of our previous servers like the X32 and the X22. And we also added a small feature that allows latency capping of read IOs. So occasionally a disk drive will have a spike of high latency, and with this feature it allows us to move the I/O to a different mirror copy instead of waiting for some sort of short latency spike that's happening on a disk drive. The main goal of 11.2.3.3.1 and 12.1.1.1 was really to improve robustness and availability. So we've rolled in all the software fixes and firmware updates that are needed to catch up with every single issue that's been reported on Exadata. And we've added a little bit of extra automatic service request support also that simplifies some of the reporting of hardware failures, so that it requires less callbacks to customers. In terms of operating system, the X4-8 updates our Oracle Linux distribution to 5.10, including all recent security updates. In the Linux kernel, the UEK kernel, we haven't made any major updates. However, we have made a number of improvements to scalability and robustness. So as we were testing the X4-8, we discovered that Linux had some bottlenecks for high core count systems. And we fixed a number of problems in the base Linux code that were bottlenecking performance, and we included those in our UEK release that goes out with the X4-8. And this is a great example of some of the benefits of Exadata, because we test the entire platform and we optimize everything that needs to be optimized, whether it's the database software, whether it's storage, whether it's firmware, or whether it's the OS. We optimize everything top to bottom. It's all completely tested and ready to go when we ship the system. To conclude, the Exadata X4-8 continues our history of innovation in both hardware and software on the Exadata platform. As time goes by, we're adding more and more capabilities into Exadata at the hardware level, and particularly at the software level, that further and further separates us from generic hardware. So I talked, for example, about some of the database and memory optimizations that only exist on Exadata, some of the database as a service prioritization capabilities that only exist on Exadata. So we continue to innovate and add more and more capabilities that are exclusive to Exadata to make it the best platform on the market for any kind of database workload. So for additional information on Oracle X4-8, please go to oracle.com/Exadata.